We have discussed about one-to-many mapping and one-to-one mapping. Now we are going to discuss about many-to-one mapping. How and when many-to-one mapping will be useful. Just a many-to-one mapping. The same one-to-many mapping. Okay. Let me consider that I have a address, okay, and there is again a country, address is there and country is there, okay, and country has country ID and country name, okay, then private string country name and okay, there is a country class which represents the country ID and country name. There is a country class which represents the country ID and country name. Okay. Now, in a practical scenario, okay, can an address have multiple countries? Can an address have multiple countries? No. Okay. Now, can a country have multiple addresses? Can a country have multiple addresses? Yes, a country can have multiple addresses. So, the relationship from address to country. What is this relationship? What is the relationship between address to country? This is a many to one. The address can have multiple countries. Okay? So, this is a many to one relationship. Let us see how we can maintain this kind of many to one relationship. Now, the address can have only one country. So, the address can have only one country. The address can have only one country. Let me override even the country. That's okay. The address can have only one country, and I have configured the country in the POJO object as well as in the association. Let me configure that in the HBM file. Just let me copy and paste this. Country.hvm.xml. Let me open country. Rest of the things are the same. Country, country ID, country name. So the country has two fields. One is country ID, another one is country name. Now, in general, see, can we have variable number of countries? Let's consider like at present in the world there are 294 countries. Okay? For application to application or module to module, will that number of countries change? If you take a banking application, it will be a list of 294 countries. If you take an insurance application, it will be a list of 294 countries. After 6 months also, it will be a list of 294 countries. Now, will that data change from address to address or person to person or something like that, application to application? Will that list change? No, that list will not be changed. So, that kind of data, we call it as a static data. Static means it will not be changed. Okay, that static data will be maintained in static tables, or we call them as lookup tables. The static data or lookup data will be maintained in lookup tables or static tables. The content of the table will not be changed. The content of the table will not be changed. The content of that table will not be changed. So, let me create a table, a static table. Okay, I have created a table with country ID and country name. Let me add some data. One, India. Two, three, zero. Let me commit the records. So the static data exists. Okay, and now the relation between address to a country is a many to one relation. In general, most of the cases, this many to one relation will be used in case of appending the static data. See, address, it has one country may have multiple addresses. One address, okay, cannot have multiple countries, but one country may have multiple addresses. Okay, like that. If you want to represent a relation to a static data, okay, in general we go for this many to one relation. Okay, let's consider like a contact will have one contact type. But what is the contact type? Whether it is a business contact or personal contact or is it office address or whatever it might be. A contact or address will have an address type. Okay. In general, what we will do? Address type will be maintained in a static table. Like one is business address, two is corporate address. Okay. Three is marketing address. 4 is personal address. Like this, the data will be maintained in a static tables or lookup tables. But there will be in the address, what we do? We'll maintain address ID, okay, street, door number, okay, and address type ID. So the address type ID will be a foreign key to address type table. Okay, so we will maintain this in such a way that 1 A 1 bar 2. Okay. The address type is 1. Now this is the business address. Okay. Now can a address have multiple address types? Can a address have multiple address types? Can a address have multiple address types? See, this is what address type I have. See, this is a lookup table, this is a static table of address types. Type 1 is business, type 2 is corporate, type 3 is marketing, type 4 is personal. So, I am creating an address table, address record with the address type 1. Okay, this is my address type. Okay, now can I have multiple address types for the same address? No, it's not possible. It's not possible to have multiple address types for the same address. But can I have multiple addresses associated with the same address type? Yes. Okay, so if you think in the address perspective, okay, many addresses will have same address type. It's a many to one relation. Okay, so this kind of static info will be associated to the main object through many to one associations. Understood? Then let me represent the same thing. A many to one association with the name. What is the name of the many to one association? Country. Name equal to country. We can specify the remaining attributes. Okay. In general, cascade will be none for many to one association. Just because since they are static, mostly many to one is used for static tables. Since they are static tables, the data should not be altered for the static tables. Okay. So in general, if we are using a many to one relationship to represent some static table information, then cascade should be none. Just because the operations of the parent should not be reflected in the child in this case, in case of static tables. So, we will give the class. What is the class? This country. And what is the column? What is the column that we represent the many to one relationship in the address? Let me add address. Let me add a column. Add underscore country underscore ID. Okay, add underscore country underscore ID, which is of type number. Now let me make it a parameter. Add foreign key constraint with country. Okay, and the column is add country ID. The referencing table is HCO underscore address, sorry, HCO underscore country, and the column is country ID. So I am adding a foreign key constraint on that. The foreign key constraint is added. So now the address has the information of country ID, which is a static reference. Okay, so whenever I delete the country, whenever I delete the address, the country should not be deleted. Whenever I save the country address, country should not be saved, just because it is a static table. Okay. Now let me try to save address. Let me see what is the information present in the address table. There is no data in the address table. Let me save the address. Already I have the address one, so for the address one itself, set country. Okay, to the country, what I will do is I will load the let me typecast it into address. Let me typecast it into country. Understood what we have done? Understood? I am getting from the session, I am getting the country information whose ID is 1, and I am setting it to address. Okay, and then let me save the address. I am saving the address. See, address 1 I have created, and to the address 1 I am setting the country, and I am setting the country by loading it from the country table whose ID is 1, and I am setting the same country to the address object, and I am saving the address object. Okay, let me try to execute this application, which represents country HBM XML is not configured in the configuration file. Let me add that. Okay, that was a mistake. Class?
Country.
Where?
Class.
Here? The HBM file of the country? Okay, sorry. Yeah, that's great. Country, it's a country ID. Country ID. Type is int. Company name. Yeah, that's fine. Now let me execute this. So first it is selecting the country. Okay, just because we have get the information, and it is inserting into the address. So the country is 1. So let me try to delete that. Okay. Just I'm trying to delete the address. Understood what you have done? Just I have executed session.get of something and I'm sending that to delete. So that object will be deleted. Okay? Understood what we have done? Just I'm getting the address post object and I'm deleting that so that it will be deleted. So if I execute the application, so it is deleted. Now is the country information deleted? No. When the address is deleted, just the country will remain as it is. The country information will not be deleted. Okay? This is how in general we use a many-to-one relation. Understood? If you want, you can write down the configurations. How many-to-one relation will be. But in most of the cases, many-to-one relation will be used to refer the static tables or static info. In that case, cascade should be none. Not the whole HTML file, just you need to write only the many-to-one tag. The rest of the things already you have seen. Okay, so now next thing, the next relation is many to many relation. Many to many. Many to many relation. Now, in many to many relation, let's consider like there is a training center where 10 batches are running, okay, and 100 students are there. Okay, can we expect that all the 100 students should be there in the same batch? No. If there are 100 students, the students will be distributed across the batches. Can we expect that the batch should have only one student? No, a batch can contain any number of students. Can we expect that a student should go for only one batch? No, a same student can go for Oracle batch, or even go for Java batch, or even can go for some other Unix or something else. So, what is the relation then between a batch and a student? What is the relation in this case between a batch and a student? It's a many to many relation. Okay? The same student can have many batches, as well as the same batch can have many students. So the relationship between the student and batch in this case is a many-to-many relationship. Okay. Now how we can maintain a many-to-many relation? Okay. Now if you want to maintain a many-to-many relation, let's consider like in the case of student and batch. Okay, the batch information is supposed to be there with the student, or student information is supposed to be there with the batch?
Student information.
Why not batch information with the student? Both should be done. Not both can be done. Both should be done. The student information should be there with the batch, as well as the batch information should be there with the student. Okay. So in a many-to-many relation, it should be possible in either way. The student information should be there with the batch, as well as the batch information should be there with the student. Okay. Now how we can achieve that? Okay. If you want to go for a many-to-many relation, in most of the cases, we go for a joint table. So the association table will represent the many-to-many relation. Rather than having two columns, rather than having batch ID in the student table and student ID in the batch table, which is a recursive, in general for this kind of requirements what we do is, mostly 99% of scenarios for many-to-many relationships like this case, what we do is we go for a joint table or a intermediate table. Okay. So let me create 3 tables. Student, student ID, let me maintain it as a varchar. Let me explain. Okay, maintenance size is 32 and it is a primary key. Name, student underscore name, so varchar, let me maintain it 50. Okay, this is not null. Okay, and let me add a table batch. Size 32, primary key. Column 1, what is it, batch, underscore name, $20 is fine. It's a not null. So we have 2 tables, batch and student. We have 2 tables, batch and student. Now let me maintain that relationship and let me create another table. Student underscore batch, where we give student underscore ID, varchar of type 32, it's a primary key. H underscore ID 52, it's a primary key. So it is a composite primary key. So the same student and batch info should not, or the same student and batch combination should not exist. Let's consider student ID is 20, batch ID is 15. With the same combination, two rows should not exist. So I have made it a composite primary key. Okay? And even I forgot that. Let me add constraints, foreign key constraints. It is a foreign key of student. Sorry, it's not student, student batch. Let me add foreign key constraints. Foreign key underscore student. The column name is student ID, and on which table means it will be on student. And okay, and even a foreign key on foreign key underscore batch. The column is batch ID and the table is batch. The column name is batch ID. So I have added two constraints, one on batch and one on student, and the primary key constraint is there on the both. It's a composite. Understood? Now let me configure the same in HBM files. Okay, I'll have three HBM files. One is student, and it's a batch. Okay, let me open student. Now the class name is student, the column is student underscore ID. Okay, sorry, it's table, right? Table name is also student, the column name is student underscore ID. This type is varchar now. Now generated class I am making it as a UUID. What UUID will make means UUID generated class will apply a specific algorithm, okay, and it will create a 32 character unique string, okay. The string generated will be of 32 character. So in most of the applications, okay, the sequence generated value will be of UUID. Most of the real-time applications, if it is generated by Hibernate means mostly they will use UUID. So that it is a 32 character and it will be unique. Student ID. Student underscore name. Okay. Now let me maintain a set batches. This is equal to all, and what else? Table. Student underscore batch, and same way of one to many. Key column. What is the key column that represents the student? Student underscore ID inside the association table. Okay, and so many to many relation. Many to many column equal to the column batch ID, the class batch, that's it. Now so what we have done? In the student, I am representing the batch information. Okay, let me do the same thing. I'll give some time to note it down. Batch, table name is also batch, the column name is batch ID, okay, the entire class is the same. Okay, batch name, we are not maintaining any relation from the batch side. It's a unidirectional many to many relation. So now let me develop the entities batch and student. Okay, student, student ID, student name, batches. Did I give the name? What is the name that I have given? Okay, batches only. This will generate this doesn't get us. The batch class is not developed, we will develop that. A batch, batch ID, batch name, Now student is ready, batch is ready. Student can have many, batchman can have many students as well as student can have many batches. Okay. Now we have configured the same in the HBM file also. A student can have many batches, that is represented in the association table. Okay, and let me try to save the information here. So let me remove all this stuff. So let me create a student, or let me create a batch first. Set batch name, CPP, C++. Okay, let me create another batch. Batch name Java. Okay, 2 batches, and let me create a student. Set student ID, set student name, Prasad, and let me create another student. I have created 3 students. Like this I have created 3 students. Okay, and let me add all the students to a set. Okay, and student set dot add s1 student 2 student 3. Okay, now I have a student set. Let me add a batch set. To the batch set, I am adding B1, B2. Now let me set the values. Student 1 dot set batches, batch set. Student 2 and student 3. Okay, and batch 1 dot set students, student set s2 dot fetch students. Okay. Now this is my many relation. First student has in 3 batches, second student has in the 3 batches, as well as third student also has the 3 batches. As well as first batch have 3 students, second batch has 3 students, third batch also has 3 students. Okay. Now let me save. Or should I save the student one information? Let me save the 3 students information. Okay, S1, S2 and S3. And let me execute the application. Same problem. Hibernate file mapping. Student. H. You must insert now into batch name. The batch name exists, right? Just give me a minute. Yeah. So it's B2, right? It's the problem. For the second batch, I did not just set the name. Okay, just it was the problem. Sorry for causing any confusion. So, first student information is saved. Okay, the corresponding batch informations are saved. The first batch and the second batch. Okay, and student information is saved. Student information is saved, the second student information is saved. Now, while inserting the second student and third student, is the batch information saved? Yes or no? See, for the first student, while saving the first student, S1, two batch information is saved. Okay? One is batch 1, another is batch 2. But while persisting the second student, is the batch information saved? No. Why not? Why the batch information is not saved while saving the, why it is saved while saving the first student and why it is not saved while persisting the second student? So, why it should not create even for second student also? See, if it is creating for the first student, why it should not create for the second student?
PDB and batch in Java, both are static. There is a lot of new batch. All are same.
It's not static. If it is static, we won't insert from our application. But the same batch is being used by student 2 as well as student 3. Let's consider like a student has multiple batches. Okay, let's consider like student 1 has batch 1 and batch 2. Student 2 has batch 2, 3. Don't consider in this case. Okay, let's consider student 1 has batch 1, batch 2. Student 2 has batch 2, batch 3. Student 3 has batch 1, batch 3. Okay, now let's consider like while persisting student 1, the student 1 information is saved, batch 1 information is saved, batch 2 information is saved. Now, if I persist the information in student 2, now, is the batch 2 information persisted again? Yes or no? No. Just because batch 1, so batch 2 already exists. So, in this case only batch 3 will be persisted. And while persisting the third student, is batch 1 persisted? No. Is batch 3 information persisted? No. Just because already batch 3 information is persisted. So, it will be like it. It will be like it in a many relation. Okay, entities will be persisted only once. Okay, but the association will be multiple. So if you see here, the association student underscore batch will be multiple. Okay, if we have 6 student batch combinations, student batch, student batch, student batch, like this 6 combinations exist. And if you see the database level also, okay, this is the student ID. This is a 32 character code which is generated through UUID. Okay, generated class. Okay, so it's not a sequence. So if you see here, it's not a sequence. Okay, some 4004, 4005 and 87001. Like this, it's not a sequence. Okay, and student name is there, and if you see the student badge, student ID and the badge ID. The combinations can be multiple, but if you see here, students are 3 and batches are 2. Students are 3, and if you see the batches are 2 only. But their combination exists multiple times in the association table or in the join table. Understood? This is how it will be. And while fetching, okay, while fetching it will make use of a join condition. Okay, while fetching the information from the database for one to many or many to many, it will make use of a join. It will join the tables. It will join the student table, student batch and batch. So it's called as a join table. Yes. In the HBM file, we can maintain it from either side, either from student or batch. If it is a bidirectional, then we should maintain it from both the sides. Okay? It's a unidirectional. See, if it is unidirectional, let's consider like person is there, address is there. If it is unidirectional from person to address, okay, let's consider like if I have person ID, can I get the address? Yes. So there what I do, person some session dot load something, okay, with person ID, I'll get the person object. If I get person dot get address, I'll get the address information. Let's consider like if it is unidirectional, and if I have the door number, I have the door number and I need to get the person information. Let's consider like if it is a unidirectional relationship, I have the address ID. I want to get the person in that address ID. Then how I can do that? Based on address ID, if I know the address, what happens? From address, can I get the person? No. For that flexibility, we maintain, if that flexibility is required, then we maintain bidirectional relations. But logically, either unidirectional or bidirectional doesn't make any difference in the database interaction or the number of queries that hit the database or the data that is saved in the database. But in Hibernate relation, to get or to access the objects or to access the either side of the relation, okay, in a flexible way we go for multiple or bidirectional relations.
So in this case we cannot fetch the batch student information with batch.
No, but we can extend so that it can be bidirectional. Understood? So let me maintain it as a bidirectional relation. So event is a the same way. Okay, students, the same table, okay, and here in perspective of the batch, the key column is batch ID. So we are maintaining it a bidirectional relationship. Now we can fetch, if we have a batch ID, we can fetch all the students. If we have a student ID, we can fetch all the batches. So it is a bidirectional relation. Now it is a bidirectional. Sorry, I am writing this outside this class tag. It should be inside the class. This was a mistake. This I have written it outside the class. It should be inside the class. So from student side we have a set of batches, from batch side also we have a set of students. So this is a bidirectional one-to-many association. Sorry, bidirectional many-to-many association. Now in this case, let me delete the information from batch. So let me delete the information from student underscore batch. And student and batch. Okay, now the tables are empty. Now in the same case, let me save the batches. Let me save the batches. Now I am not saving the students, I am saving the batches. Okay. In the same case, I have maintained a bidirectional relationship, and I am saving the student. I am not saving the student information now. I am saving the batch information. Okay. The unit constraint is violated. Where it is violated? So, from either side, from student side, let me measure this now. So, that's right. Okay, anyhow, there is some problem, but this is how we can maintain a many to many in a bidirectional relation. So, just from the student side, we have a set of batches with a association, and from batch side also, we have a set of students with an association. Okay, that's how it will be. And yeah, the next thing that we are going to discuss is second level cache or cache management in using Hibernate. Cache management using Hibernate. Okay, cache management in Hibernate. What is a cache? Why do we need to maintain a cache? Okay, and what are the advantages and disadvantages of maintaining a cache? Basically, in any software technology, cache represents a temporary memory. Cache represents a temporary memory or a memory where we save the data temporarily, where we keep the data temporarily. Okay, let's consider that we are interacting with a file system or we are interacting with a database. Okay, now here the application will be there, database will be there. Okay, we make some interactions from the application and the database. Okay, the network calls, okay, or the interactions between the application and the database will take more time. So what we do is, okay, if there is some if the data is being frequently used, or if we use the same data many number of times very frequently, what we do is, rather than retrieving that information each and every time from the database, okay, what we do is we put in a temporary cache which is a temporary memory. What we do in general is, first we have a database, we have application interacts with the database, and we fetch the data. Okay, if the data is the same, rather than fetching again and again from the database, what we do is, we fetch the data for the first time, we interact with the database, we fetch the data, put in the cache, and from the second time onwards, we fetch it from the cache first. Okay? If it is not available in the cache, then we will go for the database. So, the application to database interaction will be very slower when compared to application to cache interaction. Or the application to cache interaction will be pretty much faster when compared to application to database interaction. So we fetch the data once, and first what we will do is we'll try to get the data from the cache. If not available, we'll go to the database and put it in the cache and fetch it from the cache. So the second time onwards, if we try to get it from the cache, the information is available in the cache. So from the cache directly, we'll fetch the data. Understand? This is how the cache management will be. Okay? But irregular usage of cache, unnecessary usage of cache, okay, will increase the heap size or will increase the size allocated for these objects in the cache. So the performance will be degraded like anything. Irregular or unnecessary, okay? Unnecessary usage of cache will reduce the performance. You should be very careful while using the cache and what are the elements that are supposed to be there in the cache. If you use that irregularly without any knowledge, okay, then it will degrade the performance like anything. See, there are 100 objects or there are some 10,000 objects that are there in my heap. Okay? Unnecessarily, if you are not using, then it is a irregular or unnecessary usage of that cache. So, we should be very careful. Cache is very advantageous. That's for sure. Rather than hitting the database again and again, we can maintain a cache and we can fetch it from the secondary memory. But that is really dangerous if you don't use it properly. Just because we have the objects, we are not using that object for 2 or 3 hours or 10 hours. Then it's unnecessary and unnecessarily the heat will increase and the performance will decrease. Okay? So we should have a clear picture why we are using the cache, otherwise it will reduce the performance. But if you use the cache in a best way, it will increase the performance. Okay, it has both ends. Okay, if you use the cache without having the knowledge how it will do and what we are saving in the cache, it will reduce the performance. But if you have the correct knowledge and if you use the cache concept correctly, okay, it will increase the performance. So we should be very careful while using the cache. Understand? So now, by default, Hibernate will maintain a cache at the session level. By default, Hibernate will maintain a cache at the session level. By default, Hibernate will maintain a cache at the session level. Let me have this information with me. I have an address, I have 2 addresses and I am setting the address to person. Let me process the person information so that even address will be processed here. Okay? Now, transient object exception. Where is address? Let me remove this association, not required. Person has a address set. Cascade equal to all. Let me maintain the cascade all so that the person and address or information are saved. So now the person information and address information are saved. Now let me comment it, not required at present. Now what I am doing is okay, I have a person with the ID 1. Okay, now I am trying to get the information from the database. Okay, and let me get it twice. Let me get it twice. Now let me execute the application. So how many times it is fetching the information from the database? 2 times or only once? Is it fetching the information from the database twice or only once? Once or twice? Only once. This is the person information and this is the corresponding address information. Now how many times I have executed the get method? Twice. Let me execute it more times. I have executed some 6 or 7 times. Even in this case, how many times it will fetch the information from the database? Only once. Okay. How and why this is, or how or why the records are fetched only once? Okay, means because of the cache management at the session level. Okay. By default, Hibernate will maintain the cache at the session level. Okay. So if the session has that info, first there will be a cache maintained at the session level. So let's consider like let's consider this is the cache which is there at the session level, and then first the Hibernate framework will try to interact with the database. Okay, sorry. Whenever we try to get something using the session, first Hibernate framework will try to fetch it from the cache. If not available in the cache, then it will interact with the database and fetch that information from the database, put in the cache, fetch it from the cache. Let's select for the second time. Now, this is the first time where this is the first statement where I am interacting with the database for the person ID 1. So, for the first time anyhow it will not be available in the cache. So, a database interaction will happen. Okay, a POSA object will be created and the POSA object will be put into the cache. And from the cache, Hibernate will fetch that to the application. For the second time, okay, in the 31st line, again the same record is required. The same record is fetched. Then for the second time, is that object there in the cache? Is that object exists in the cache? Yes. That object exists in the cache, Hibernate will not fetch again from the database. Okay, Hibernate will not read the database, directly it will fetch from the cache. So by default, there will be a cache available at the session level. Understood how it will be? Okay, by default, session level cache will be available for a Hibernate application. This session level cache is said to be, in general, we call it as a primary cache. The session level cache is called as primary cache, or even we call it as first level cache. We can call it as either a primary cache or a first level cache or even a session level cache. Both are the same. Either we can call it as a primary cache or a first level cache or session level cache. Okay. Now, by default, session level cache will be available to any session. To any session, the session level cache will be available. So, now there is a method in session. Yes. Yes. It is. It will not degrade the performance until we properly use that. See, that means we should properly use the objects in the session. Okay, it's available, but we should properly use the objects in the session. Okay, now let's consider like we have another session. Session 1, session 2. Okay, session 1 and session 2. Just if you go for session 1, session 2. Session 1 dot begin transaction and even session 2 dot begin transaction. Okay, now how many sessions are there? 2 sessions, session 1 and session 2. Now let us see in this case how many interactions will happen to the database, or how many interactions will be there with the database. How many interactions are there with the database? Is it 1 or 2? 2 interactions are there with the database. Why? Why here cache is not maintained? Okay. Is cache maintained here or not? Okay. Cache is maintained here, but for each and every session a separate cache is maintained. But so if I execute session 1 dot get once again and session 2 dot get once again. Okay. Now how many interactions will be there for the database? 2 only. Just because the cache will be maintained by default at the session level. Okay. Understood? Now in general what we'll do is for each and every user we'll create a session. Now let's consider like the person information. Okay, the person information. Let's consider like I am the student. I have logged into my application. My information can be there in my session. That is fine. That is restricted to the session level. Let's consider like my country information. There are 3,000 students in the university. Most probably they'll belong to the same country, or most probably they will have the same set of states. Let's consider like I have a list of states to be populated. Now will that list of states will vary from one student to another student? Let's consider like a student should select one of the states from the 26 states. Will that 26 states vary from one student to another student? No. The 26 state information will be the same for any student, but the student personal information will vary. So the student personal information will be maintained in his session. But this state information or the country information, will it vary from one student to another student? No. For any student there will be 26 states and a list of countries. So is this information, is the information of states, is the information of list of states, is it common to all the sessions or is it specific to a session? It's common to all the sessions. If it is common to all the sessions, why we should maintain it at session level? And if it is fetched for all the sessions, what happens? Let's consider like there are 1,000 users. There are 1,000 users, 1,000 database interactions will happen for that state. Okay, and the same information is fetched for any session, for any student. If the information is the same, why to fetch that 100,000 times or 10,000 times? If the information is the same and it will not change, whether if we fetch 1,000 times or 10,000 times, it will not change. The same information will be fetched. But is there a possibility that we can fetch the information only once and put in some cache. Understood the point? Understood my requirement? For this kind of requirement, session cache will not be the thing that we need to use. Okay, we cannot use session level cache for these purposes. So, for this kind of purposes, in Hibernate framework, there is another cache maintained, which is, we call it as a secondary cache, or we can call it as second level cache, or this cache is maintained at the level of session factory. The second level cache is maintained at session factory. It's not the session level cache, it's a session factory level cache. It's a session factory level cache. So, is the session factory same or different for different sessions? The same session factory will exist for any number of sessions. Even if we have 1 lakh of sessions, the session factory will be only one. So, whatever the information that we maintain in the second cache, it will be at the level of the second session factory. So, if you want to enable the session factory level cache or second level cache or secondary cache, we need to do some settings in the configuration file. What are the settings that we need to make? Is where is it? It is in the configuration file. We need to do some settings. What are the settings that we need to do is by default this is the first attribute that we need to set. What is the cache provider class? Okay. For caching, we have a jar file named EH. Okay, this is a jar file which is one of the vendor which maintains the second level cache. Okay, there are several third-party jar files which are used to maintain the second level cache, like EH cache, Swarm cache, OS cache. Like this, there are several vendors who will provide the jar files to maintain the second level cache. Other than this, there are tens and hundreds of jar files or hundreds of applications which will maintain the second level cache. But for our application, we'll use EH cache to maintain the second level cache. These are some of the things, some of the third-party vendors which will maintain the second level cache. These are third-party applications. Okay, they have exposed their applications as jar files. So, this EH cache.jar will have the information or will have some application which is used to maintain the second level cache. The package is net sf EH cache EH cache. So now the package is, its class is net.sf.eh cache. Is it net.sf.eh cache dot The class name is ehcache.class. This is the cache provider class. Which class will provide the second level cache? What is the third party class that will provide the second level cache? Okay, and by default the cache provider class value will be no cache provider. There is a class in Hibernate itself which is called as a no cache provider. Okay, it will be available by default in Hibernate itself. Okay, no cache provider will be available by default in Hibernate. This is the default value of cache provider class. The default value of cache provider class property is no cache provider. So no second level cache will be available. This is the default value for cache provider class, which is a no cache provider. So default second level cache will not be available. Okay. Understand? So by default second level cache will not be available. That's why the cache provider class by default will be no cache provider. So we need to override that in such a way that we will provide some cache provider, but it is not a thing. Let me see whether there is some class like cache provider is there, so we should use that now. Since we are using cache, we should use the cache provider. It's not the cache class that we should not use. We should use the cache provider. Okay, it was a mistake from my side. I thought that it will be like the class of the jar file, but it's not like that. We should provide the cache provider. The cache provider class is now cache provider. And then the second thing is, once the cache provider is available, the secondary cache provider is available, we should go for another property. Use second level cache. I suppose use second level cache is the property. Let's see. By default it will be false. Should make it true. By default this flag will be false. We should make by default secondary level cache will be false. We should make it true. Okay. In the configuration side, we need to do these two things. Okay. What is the cache provider class? Okay. What is the second level cache provider class, and whether to trigger the second level cache or whether to use the second level cache or not. We'll trigger the flag which is use second level cache. By default the value will be false, we'll make it true. Okay. Now, once this configuration is done, the next thing that we need to do is wherever we want to maintain the cache, for whatever the entity that we want to maintain the cache, okay, we will specify cache. We will specify a tag cache, okay, a tag cache with attribute usage. A tag cache in the class tag with attribute usage. Okay, the usage attribute will specify the mode of the cache. The usage attribute of the cache tag will specify the cache mode. The usage attribute will specify the cache mode. Okay, the default cache mode is read only. The default cache mode is read only. That means the cache will be applied for only read only transactions. The cache will be applied only for reading. Okay, the default value or the default usage of cache is read only. So, only for reading or only while fetching, only for select, the cache will be maintained. But we can change the cache mode so that it can be read or read write. Sorry. These are the values: read only, read write, non-strict read write, and transaction. These are the four values. The default value and the mostly used one is read only. But read only will be used when we are supposed to maintain the cache while reading, okay, or while fetching the information from the database. In 98% of scenarios, we use read only as a cache mode or cache usage, just because cache is supposed to be used in most of the scenarios while fetching only. Okay, but there are possibilities for read write. We use read write, okay, if we want to maintain the cache of some information which is continuously updated. Okay, if you want to update some information and if it is supposed to be continuously updated or very frequently updated, then for that entities we maintain the read write usage. Let's consider like if we update that for 100 times. Okay, if you update that for 100 times, then in that case we maintain the cache as read write. And when we use non-strict read write means if we read that frequently but writing happens very rarely. If you want to read that frequently but writing happens very rarely, then we go for non-strict read write. And transaction means like for any transaction, either read or update or delete or any transaction, okay, the cache should be maintained. But transaction, even read write is very rare. 98 to 99% scenarios we use the cache mode or cache usage as read only. So let me make the cache usage as read only. Transaction means for any transaction, for any kind of database transaction, not only reading or writing, deleting, like that. Okay.
What is the difference between the read write and transaction?
See, read write is only for read and write. Transaction means, see, other than reading and writing, we can perform any kind of database interactions.
Update.
Like deleting. Writing is also updating, right? Writing means either insertion or updation. But like deleting or altering or any kind of database interaction, it will be available. See, reading and writing are not the only database interactions that we have. There are several other database interactions. For all the database interactions, cache will be maintained if you go for transaction. But keep it in mind that we should use the cache properly. Improper usage of cache will reduce the performance. But the best usage of cache will boost up the performance. So now the first thing is we should go for these two properties. Cache provider class, cache use second level cache attribute as true. Okay, and the next thing is in the HBM file we should maintain the cache usage. Okay, and in the client application, let me see what it is. Let me see now. Okay, now we have maintained a second level cache, session factory level cache for person. Okay, we have enabled the cache for person. So let me see. How many times the information is fetched from the database? Only once. Even it is for different sessions. It is for person and address. But this information is fetched only once. Even it is fetched through two different sessions. Okay? This combination, let's consider like if you don't have these attributes. Let me comment this. Okay, if I comment them, then sorry. If I comment them, then I should comment even this also. So how many times information is fetched? Once for one session, second time for the second session. Okay, but let me uncomment this. So now the cache is maintained at the second level or the session factory level. So how many times the information is fetched from the database? Only once for person, but for address it is fetched twice. Just because address is not maintained in the second level cache. If you want to maintain even address in the second level cache, we'll use the same thing. So even for address now, it will get it only once. Okay, let's see after. But yes, the second level cache can be maintained. Okay, at the session factory. Okay, so if you maintain the session level, session at the session factory level, or if you maintain the cache at the session factory level, okay, the information will be available in a temporary memory which is maintained by the session factory. So it will be common for all the sessions. Okay, so this is how we can maintain a second level cache. Okay. Understood how section level cache should be maintained? And I think we can modify the cache. And one more thing, one more important thing is, if you want to remove a specific element from the cache, okay? If you want to remove a specific element from the cache, what we'll do is, let's consider like if I want to remove this element from the cache. Okay, now how many times it is fetched? Let's consider like now for these 4 interactions, how many times the information is fetched? If the cache maintained at the second level, only once. See, if this cache is maintained at the second level or the session factory level, the information is fetched only once. Now, in the session factory level, we should evict the whole class. We cannot evict a single object in the session factory level. We should evict the whole class, all the objects of this class. After evicting, let me put a star. After evicting, then what I'll do is, again I'll try to fetch the information from the database. Evict, what it will do means, it will remove all the POJO objects of that class from the session factory level cache. Okay? It will remove all the POJO objects of that class from the session factory level cache, second level cache, or session factory level, or secondary cache, whatever it may be. Okay. So if I execute the application, first, why it is not evicted? So, since the session was created before eviction, since the session was created before eviction, it will behave like the same session. Let me create another session. Session 3 equal to session factory dot open session, and using session 3, if we fetch the information from the database, okay, let me try this way. So, now is it fetching the information from the database? Yes. Why it is not fetching the information from the database if I use session 1? If I use session 1, why it is not fetching the information from the database? See, if I use session 1, is it fetching the information from the database or the cache? Cache itself. Just because this session was created before eviction. If I create a session after eviction, if I try to fetch the information from the database, okay, now, so using session 3, if I fetch the information from the database, click it from the database.
Without giving the evaluation statement that if you go to the session, it will again connect the data,
If we
so that's a dot statement.
let's consider like if I remove evict and if I create another session, will it fetch from the database? Will it fetch from person record from the database? Is it fetching person record from the database? No. Even for a new session of, or even if we create 100 sessions, it will not maintain. By evict is used means if you want to remove a specific class or a specific Pojo class objects from the session factory cache, or if you want to clear them from the session factory cache or the second level cache, we use evict method. Even in the session also we have evict method. Using the session dot evict method, session 1 dot, one second, let me complete this. There is evict method even in the session. The evict method in the session will take an object, so that only one object, that particular object will be removed from the cache of the session. But the evict of the session factory, what it will do means it will take the session factory evict method. The session factory evict method will take a class, will take a Pojo class, so that all the objects corresponding to that project class which are there in the second level cache will be cleared. All the person objects present in the second level cache will be cleared. Okay, now ask your doubt.
When using the session, when it is bringing back the data from the bytecode cache?
No, yes. What you told is correct. See, whenever I have a session factory, okay, and if I maintain the caching at the session factory level, okay, and internally if I am using a session to get the object information, then the information will be there at the session. Again, if I try to use the same session again, it will not go to the session factory. It will get it from the session itself. Understood? See, first it will go to the database for the first time. It will maintain in the session factory. Now let's consider like I have created a session, okay, and that information using that session I am fetching the information, okay, and from the session factory cache the information will be put in the session. So using the same session, if I try to fetch the information again, will it go to the second level cache or will it try to fetch it from that session itself? That session itself. If the information is not available at that session, then it will go to the session factory. Okay? Yeah. There is another cache, a third type of cache which we call as a query cache. It's already late, so we'll discuss the query cache in the next class. In the next class, first we'll discuss about the query cache, okay, and then we'll see about the inheritance patterns, okay, how inheritance can be achieved in Hibernate, okay, that we'll see in the next class. Hmm?